Welcome back to another video. Today we're going to talk about dilating a figure in the coordinate plane. So first, when we talk about dilations, we have to talk about what a dilation is. So our definition of a dilation is going to be a proportional stretch or shrink. So it's going to be the stretch or shrink of a figure, but it's going to be done proportionally, meaning all of the sides are going to have the same scale factor when we stretch or shrink that figure. Dilation notation in the coordinate plane is a capital D. The subscript is a P. This would be any point. That's my center. So I'm going to write center point, followed by a comma and then a number. So for example, 2. And that would be whatever the scale factor is. So looking at example 1 here, we're given a triangle ABC with vertices at A, 1, positive 3, B at negative 2, positive 2, and C at 3, negative 1. I need to graph, label, and state triangle A prime, B prime, C prime, which is the image of triangle ABC, after a dilation with a scale factor of 3 centered at the origin. And I'm going to state those coordinates. So whenever we dilate a figure, first we have to pay attention to its center. So we're going to count from the center to each point. So starting at my center, which is the origin, I'm going to count up to point A. So I would go up 1, 2, 3, and over 1 to get to point A. Now there are 2 ways to do this, but the way that I like to do it is to say that that is a scale factor of 1, and I can tell because I already have 1 slope triangle drawn. So now to make it a scale factor of 3, I'm going to repeat that process. I'm going to continue at A, going up 3 and to the right 1, but now I only have 2 slope triangles, so that's a scale factor of 2. So I'm going to do it a third time to get a scale factor of 3. 3 slope triangles means that I have dilated it with a scale factor of 3. And notice that that point, A prime, is 3 times as far away from the origin as point A. So that's another thing that happens, is when I dilate a figure, it gets further from my center. So I'm going to repeat that process with B and C. So to get to B, I went over 3, right 1, over to the right 3, down 1. So I'm going to repeat that process 2 more times to get C prime. And for B, I would go up 2, left 2. So I'm going to repeat that process 2 more times. Once I'm done, I can connect my points of my new shape because it does tell me to graph and label the triangle. And then it tells me to state the coordinates. So again, I always use parentheses, and my coordinates are always an x coordinate followed by a y. So for A prime, it's at 3, positive 9. B prime is at negative 6, positive 6. And C prime at 9, negative 3. I want us to really quickly take a note and see if we see a relationship here between the points in my pre-image and the points in my image. Because this is centered at the origin, all of my points were multiplied by the scale factor. So when centered at the origin, your coordinates can be multiplied by the scale factor. That's especially helpful if your scale factor is not an even number like 3, if it's a fraction, 4/3, or even a fraction like 3/4. It's going to be hard to count that, so it's easier to multiply. So now let's look at example 2. Again, we have a shape, we have a figure, a quadrilateral this time. Coordinates are -6, +8, -3, +4, 4, +2, and 6, +6. This time we're going to dilate it with a scale factor of 1/2. So to dilate this with 1/2, we can either, because this is centered at the origin, I can either count or I can multiply. I'm going to show you how to count. And then we're also going to multiply. We'll do this one both ways. So starting at the origin again, which is my center, I'm going to count. Let's go with F first because it's closest. It's easier for me to see. So to go to F, I would go up 2 and right 4. But I don't want to go all the way to F because my scale factor is 1/2, so I only want to go half as far. So instead of going up 2 and right 4, I would go up 1 and right 2 from my center, and that is F prime. I could do the same thing for G. To get to G from my center, I would have to go up 6 and over 6. But because the scale factor is 1/2, I only want to go half as far. I only want to go up 3 and over 3. Now for point D, I'm going to multiply. D and E, I'm going to multiply. So for D, the point was originally -6, 8. So I'm going to multiply that by my scale factor. -6 times 1/2 is -3. 8 times 1/2 is +4. And I can plot that point. Oh, look, it just so happens to be right on point E. Now I'm going to do the same thing for E. I'm going to multiply those coordinates. -3, 4 is the original. So I'm going to multiply each by 1/2. -3 multiplied by 1/2 is -1.5, or you could put -3 over 2. Usually we'd like to use fractions. And then 4 divided by 2 is 2. Or dividing by 2 and multiplying by 1/2 are the same thing. So now I can plot that point. -1.5 up 2. Here is point E prime. And now I can connect my points to make my new figure. And I need to still state F and G. Are these figures congruent? So we're going to see what congruent means. Congruent figures have all their corresponding parts equal to one another. So corresponding sides are equal and corresponding angles. Looking at these figures, the corresponding sides are not equal. In fact, they're in proportion. They're proportionate. So these are not congruent. Dilations do not preserve distance. And I'm going to write in, I'm going to put a comma and write that corresponding sides are proportional. Now I am going to make a little note here that corresponding angles in a dilation are still equal or congruent. Let's look at this next question. Triangle ABC and point D are graphed on the set of axes below. We're going to graph, label, and state A prime, B prime, C prime, which is the image of ABC, after a dilation with a scale factor 2 centered at point D. So this time, my center is not the origin. In fact, it's not even a point on my shape. It's a random point. But let's see if our strategy is going to be any different. Starting at our center, we're going to count to each of our vertices. So starting at point D, I'm going to count up 3, right 1, up 3, right 1. Because the scale factor is 2, and now I have 2 slope triangles, I'm done with my dilation. That didn't seem much different from what we've done before. Let's try again. Let's go to A. Left 3, down 1. Left 3, down 1. A prime. Nope, that still seems very similar to what we just did. All right. Point C. Right 3, down 3. Right 3, down 3. Here is C prime. I'm going to erase these hops that I have in the middle here, my slope triangles, so that it's easier to see my shape when I draw it. And here is my new figure. I have graphed and labeled it according to the directions. So now let's look. How is example 3 different than the first 2 examples that we did? Well, it is not centered at the origin. It is centered at another point. Is our strategy any different? The answer is no. We can still use slope to dilate. But I'm going to write a little star and say we cannot use multiplication. We can only use multiplication if it's centered at the origin. All right, we're going to do one more. Triangle XYZ is located at X 2, +5, Y 4, +3, and Z 0, +2. And I'm going to graph, label, and state, just graph and label the coordinates of X prime, Y prime, Z prime, the image of XYZ after a dilation scale factor 3, centered at point X. All right, let's try this again. So we're going to start at our center like we've been doing. So starting at my center, which is X, I'm going to count right 2, down 2 to get to Y. So I'm going to continue that pattern, right 2, down 2, Write 2 down 2 3 times because I need 3 slope triangles for a scale factor of 3. Now I'm going to dilate point Z. My center is X, so I'm going to go left 2, down 3, left 2, down 3, left 2, down 3. Here's point Z prime. Notice that because point X is the center, X can't move away from the center. It's already there. So X is going to be an invariant point. It did not move during the transformation. That's all I have for you today.